We're going to do the first question on the exam, and it asks us to calculate the potential difference between 2 points B and A that they give us, and they give us a rod and a disk which is located a distance d minus h plus over 2 from the disk. So, in order to calculate the potential difference, the first thing that we need to realize is that the change in potential difference is equal to the negative integral of E and dl. So the first thing that we need to write down on our paper is just that equation. And the next thing that we need to realize is that we have the rod and the disk to account for. So now what we have to do is we have to split our E into two different parts. And we need to split it with the disk and the rod. So now we do negative E disk plus negative E rod dl. And we're going to need to take the integral of both of those separately. So we know that the E of the disk is equal to Q over A 2 epsilon naught, and the E of the rod is equal to 1/4 pi epsilon naught 2Q over L R. So now we need to take the integral of both of these, and the first thing that we need to do when you take the integral is to figure out its bounds. So we know from the question that the disk is d minus h over 2 away from A. So for the integration bounds for that, we have b minus a, so we're going to have d minus h over 2, because that's your A point, and then to figure out what your B is, you need to realize it's d minus h over 2 plus this distance h, because the distance from A to B is h, which makes this, when you add both of the things together, it's d plus h over 2. And now you're going to plug the E disk formula that I told you guys earlier, which is Q over A 2 epsilon naught, and you're going to add it to the E of the rod right here that we also told you guys earlier. And you have to find the integration bounds for that as well, and we'll get to that in just one moment. So, to figure out the integration bounds for the rod, what you have to realize is we already found what B was, and that's going to be the same, because the distance that the rod is away from point B is the same as the distance that the rod is away from the disk. And we already found that, so we know that is negative d minus h over 2, and it's negative because we're going in the negative x direction from the rod. Before, we were going in the positive x direction from the disk, which is why this integration bound was positive, and which is why this integration bound is going to be negative. So you have to be careful with that. And to find A, we're going to do the same thing that we did to find B for the disk, and that's going to be to do negative d minus h over 2 plus the plus the h. So we're going to do negative d plus h over 2. So that gives you the two integration bounds for the disk, and now we're going to integrate all of this with respect to x. So that becomes dx. And you do that by doing q over a 2 epsilon naught. That all is a constant, and you have dx, which becomes x, and then you're going to take the integral from d minus h over 2 and d plus h over 2. So once you do that, then you get q over a 2 epsilon naught d plus h over 2 minus d minus h over 2. And you did all of that work just for the disk. So now you have to do the same thing for the rod. So we know again that that part is 1/4 pi 2 epsilon naught 2q over L. That all is just a constant, and you're taking the integral essentially over 1 over x. And it's the same thing. So you end up with ln of x, because the integral of 1 over x is ln of x, and you have your integration bounds that you have to take the integral from. So it's going to be ln of x from negative d plus h over 2 minus d minus h over 2. And you have all of that, and you have your constant, which is q over L 2 pi epsilon naught. And once you evaluate all of that, then what you end up getting is q over h 2 epsilon naught a minus q 2 pi epsilon naught L. and then ln of d minus h, and then d plus h. And what I did here is just the ln property, where when you subtract two of the items, you just put them one over another because it's the log property, where when you subtract things, it's just the same thing as dividing them. So that is what gives you your final answer when you simplify all of that, and that's how you do problem number 1. Thank you.